Okay, we're going to take a look at the homework. Number 1, Mai and Tyler work on the equation 2 over 5b plus 1 equals negative 11 together. Mai's solution is b equals negative 25. Tyler's is b equals negative 28. Here is their work. So we've got Mai's work and Tyler's work, and we've got to decide who completed this correctly, because they got two different answers. So we can assume that at least one, if not both, has an incorrect answer or solution. So let's just go through step by step and see if we can first figure out what they did each step, and then determine, is what they did mathematically acceptable, correct? So let's take a look at the first step. So 2/5 b plus 1 equals negative 11. So if I look on the left-hand side, my 2/5 b stayed, but the plus 1 is now gone. So it's fairly obvious because the b stayed the same. The 1 disappeared. There wasn't anything to simplify that she felt was necessary. So we can assume that she subtracted 1 from the left side, or added negative 1. So if you add negative 1 to the left, she should have added negative 1 to the right. Now if we look here, negative 11 became negative 10. Negative 11 minus 1, or negative 11 and negative 1, actually equals negative 12. She got negative 10. This is a problem. She has an error. So if we take a look and see what actually happened, to make negative 11 become negative 10, she actually added 1. Let's take this part out. She actually added 1 to the right-hand side. So she added negative 1 to the left, positive 1 to the right. Whatever you do on one side, you have to do on the other. Be very careful, because if you haven't practiced your positives and negatives, and you're not thinking through exactly how adding these kind of numbers work, you will get caught with an error. So please be very, very careful. Okay, sorry about that. I had to adjust. Okay. So at this point, we know she is wrong automatically. The only thing is, I want you to continue. We're going to continue looking at what happened in Mai's problem, because she does something really interesting next that I want to make sure that you see. All right, so we're going to take a look here and see what she did right here. Because even though she made an error, we're still going to continue, because we have 2 over 5b becomes b. Negative 10 becomes negative 10 times 5 over 2. So on this right side, she all of a sudden multiplied 5 over 2, but didn't multiply anything on the left side. I don't see anything multiplied over here, but I see a 5 over 2 magically appear. That doesn't automatically mean she did something wrong. There's absolutely a chance that she kind of completed multiple steps at once. So to kind of solve this mystery, this 5 over 2 that magically appeared, to be multiplied. Whatever she does on the left, she has to do on the right. So maybe there's some sort of connection between the 5/2 and the 2/5 up above. On a side note, if I had 3b equaled 12, mental math, you could probably easily tell me b is 4. 3 times 4 equals 12. The only thing is if I showed you the answer and I said, how could you explain getting from this step to this step, just like we've been doing? Well, you would look at this and say, okay, well, 3b became b, 12 became 4. Well, if I subtract 2b, that works on the left side, but subtracting 2b does not work on the right. So most of you would tell me, well, they divided by 3. 3 divided by 3 is 1, so I get b. 12 divided by 3 is 4. So one of the ways to eliminate this coefficient number, because it's being multiplied, you can undo that with division. So if you look through our examples, that's what's been happening a lot of times towards the end of our equations. So maybe the same type of process was used in this step. The only thing is, I've got division and I have a fraction. So if I wanted to take 2/5 b and divide by 2/5, let's think about that for a second, because dividing fractions, if you remember correctly, you never really divide the fractions. If I rewrite this, imagine the b is still going to be there, but if I were to do this division, you leave the first fraction the same. Division becomes multiplication, and the next fraction becomes the reciprocal, or gets flipped, your teacher might have said. So in order to get rid of the 2/5, you actually multiply by what's called the reciprocal. Now, if we back up to here, one of the other things that we talked about when we were solving is, I've been saying dividing by 3 is the same as multiplying by what? 1/3. Dividing by 3 is the same as multiplying by 1/3. Dividing by 2 is the same as multiplying by 1/2. If I look at 3 and 1/3, 3/1 and 1/3, that's the reciprocal. Any number times its reciprocal equals 1, just like any number divided by itself equals 1. So finally, if we come back to what Mai did over here, she actually multiplied each side by 5/2. On the left, my numbers cross cancel and I have just b. Now, I'm assuming that she didn't do the math on the right side just so that you could see the step. But if we actually set this up to multiply, -10 times 5 is -50. 1 times 2 is 2. -50 divided by 2 is actually -25. So what she did was okay. She multiplied each side by 5/2 is all she did on this step. And there's nothing wrong with that. But be aware that this is a possibility. You're not always going to get a perfect little number over on as a coefficient over here. So be very careful. Let's look at Tyler's work. All right, so Tyler started with the same equation, and let's see what he did for his first step. So on his first step on the left side, 2/5 b became 2. The 1 stayed the same. And over on the right, -11 became -55. This one might be a little trickier to see because 2/5 became 2. The ones didn't change. So it looks like we did a little adding and subtracting with the b's. So something got added or subtracted with our b's. The only thing is whatever I do to one side, I have to do to the other. So if I'm adding or subtracting b's on the left, I would have to add or subtract b's on the right, but I don't have b's. So we're going to come back to this in a second. Let's focus on what happened on the right-hand side, just because its numbers might be easier. Well, -11 times 5 is -55. Whatever you do to the right, you have to do to the left. So let's multiply the left side by 5. Now look at this for a second. 5/1 times 2/5 my 5's would cancel and I would get 2b. That's where this 2b came from. He multiplied by 5. The only thing is the entire side has to get multiplied by 5. The whole side has to get multiplied by 5. Which means the 5 actually has to get distributed because whatever I do to one side has to happen to the other side. And when you multiply, everything on that side gets multiplied. I'm taking everything on the left and increasing it 5 times. So the error is right here. You should have multiplied the 2/5 b and the 1 by 5. Everything needed to get multiplied by 5. Now from here, he actually did everything mathematically correct. 2b plus 1 becomes 2b. He subtracted 1 from the left or added -1 to the left, -1 to the left, and -1 to the right. The math is correct. And then for 2b equals 56, divided each side by 2. So both of these people made errors and did not complete the equation correctly. Number 2. Well, now you're going to have to answer this question. The explain or show, we did that with all that work. All right, number 2. Solve this equation. Sorry guys, give me 1 second. There we go. Okay, solve this equation. Now, if you think back to the notes, we actually have options. The first step was to simplify, and sometimes you're going to look at an equation and you're going to feel like you can solve this without simplifying. And it's set up in a way that actually works out a way you like. So if you struggled with this, I'm going to show you a couple different options. And I want you to complete the option that you prefer. So first thing, we'll try with the simplify. And by simplifying, I'm going to look on the left and the right to see if there's any math I can do to kind of clean everything up. And I actually have a 3 on the outside of these parentheses that I can distribute. 3 times x is 3x minus 3 times 4 is 12. Nothing I can do on the right-hand side for now. So now if we start imagining this as a set of hangers with items on each side, I've got to keep everything balanced, but eventually I want the x's on one side of my hanger and the numbers on the other side, because that will show me what each x weighs or equals. So I want to get the x's on one side together, the numbers on the other side. So if you can imagine my hanger, I have 3x on one side and negative 12. And on the other side, I have 12x. So in order to balance this out, remember we need x's on one side of the hanger, the numbers on the other side of the hanger. So I already have 12 x's on the right-hand side, so maybe it would be good to take these 3 x's and remove them from the left side. So I'm going to take negative 3 x's. Let me fix this. On the left side, because if I have 3 positives and 3 negatives, they'll cancel. And then on the right-hand side, I'm going to have 3 negative x's. Now here's the thing, if I have 12 positives and 3 negatives, I'm actually left with 9 x's, right? 12 positives, 3 negatives. Now if I transfer what I did over here to my equation, I took those 3 x's from the left away, moved them to the right. Those cancel and I'm left with 12 negatives. 12 and negative 3 makes 9x. Now remember, this minus 12 means I have 12 negatives, so that everything's got to come down here. So now from here, if we looked at the hanger, I have 9 x's on the right and negative 12 on the left. I want to know how much if 9x equals negative 12, I need to know how much 1x equals. So I've got to take my 9 x's, and if I divide them into 9 groups, I'm left with 1x, right? Well, if I divide the right side by 9, I've got to divide the left side by 9. So I'm going to divide this into 9 groups. So I would have to divide this into 9 groups, right? Divide each side by 9. X equals negative 12 ninths. Now you can simplify that, and you get negative 4 thirds, and that's okay too. Now we're going to take a look at what if we didn't simplify first. Okay, so for the next one, what if you looked at this and said, well, I don't want to distribute this 3. I want to eliminate this 3 from the beginning. Okay, And what that would look like with the hanger, just so you can see, this means I have 3 groups of x minus 4, right? So I have 3 groups of x minus 4 on the left. And on the right, I've got 12 x's. So if you don't want to simplify from the beginning, maybe you look at this and say, well, I can break this into 3 groups. Well, if I divide the left into 3 groups, I've got to divide the right into 3 groups. Well, to divide 12x into 3 groups, I have to do a little bit of math, right? So I'm going to rewrite this. Instead of 12, I'm going to write 3 groups. So maybe this is how you see it. Maybe you see, okay, well, there are 3 groups. So each x minus 4 can be grouped with the 4 x's. So maybe what you want to do from the beginning is divide each side by 3. Because you notice that, well, 3 is being multiplied, so I can undo it by dividing. And 12 is a factor, or excuse me, is a multiple of 3, so I can divide 3 out there. This whole side is divided by 3. But really, I'm able to cancel out my 3's, and I have x minus 4 equals 4x. So if we focus in on what's happening right here, I've got x minus 4 and 4x, right? So just like our hanger on the left over here, I can do the same type of process and say, okay, well, I already have x's waiting over on the right. So what if I take an x from this side, negative x on the left, and a negative x on the right? So I'm placing a negative x on the left and a negative x on the right. Positive and negative cancel each other out, and I'm left with 4 negatives on the left, and on the right, I've got 3 x's. Because if I have 4 positive x's and 1 negative x, together they make 3x. So I'm left with negative 4 equals 3x. Now, just like our other, if I have 3 x's, maybe you want to break these up into groups. 3 is multiplied by x, so I can divide it. And if you see, I got negative 4/3, just like we got on the other side. Now, you can take a look at the 2 options, see which you prefer at the moment. On the right-hand side, it didn't end up really saving us much work by dividing out that 3. Sometimes it will. And I want you to see that process, because there will be times where that actually saves so much work. In this case, not so much, but I wanted you to be able to see that. So take a minute, rewind if you have to, and you choose which you want to copy. Definitely copy the hanger down, especially if you struggled on this question. All right, number 3. Describe what's being done in each step while solving the equation. So all we're doing is going through the steps and explaining what happened. So from our first Let me cover these up here. So from the first line to the second line, get something different. There. The right side, or excuse me, the left side did change. The right side did not. So we know this is going to be something simplified. Now remember, we're not checking for correctness, we're just describing what happened. So if I look on the left, well, the 2 in the parentheses disappeared. Whenever we have a number outside the parentheses like this, we can distribute. And if we look at the numbers, 2 times negative 3x is negative 6. 2 times 4 is 8. So they distributed the 2. That's just a straight simplifying step. Let's look at the next step. We can move our paper if we need to. 8 equals 11x plus 2. So let's see what changed from one step to the next. Well, something happened here because all I'm left with is an 8. On the right-hand side, my 2's stayed the same, and something happened there. So on the left side, for my negative 6x to disappear, negative 6x plus 6x cancels out. What's 5x plus 6x? 5 plus 6 is 11. So we added 6x to each side. If you see here, negative 6 plus 6, 5 plus 6. From here, I want you to finish this part on your own. Pause here and see if you can get it, and then check yourself with me. Now's the time to try it on your own. Okay, hopefully you saw 8 became 6, and on the right side, the 2 that was being added disappeared. 8 and negative 2 is 6. 2 and negative 2 is 0. So we added negative 2 to each side. This last step I want you to try on your own. We do see the x went from the right to the left. So there is some rearranging that happened, but that's not what I want you to find out. I want you to figure out, how did 11x become x and 6 become 6 over 11? Okay, well, the 11x to x, you could have taken away a 10x, but I can't. 6 and taking away 10x doesn't work out. So we've got to look at either multiply, divide type of a situation. So 11x divided by 11 is x. 6 divided by 11 is 6 over 11. Don't forget, you guys, 6 over 11 means 6 divided by 11. So if I divided 11 on both sides, 11x divided by 11 is x. 6 divided by 11 is 6 over 11. That's why we see this fraction there. All right. Now the last problem you're going to do on your own. Andre solved an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but he can't find it. Where's Andre's mistake? What is the solution to the equation? So, your job is to find the mistake and then figure out what the solution is. Find the error, then you solve it. So off to the side, you're going to want to rewrite this. And you're going to solve it yourself. Now, the last thing is you are actually also going to complete 5 and 6. This is a day of lesson 4 homework. Couple little reminders that I want you to jot down before you finish up here. Choose the equation that has solutions 5, 7, and 8, 13. This is review, Unit 3, Lesson 12. We've been talking about solutions, but our solutions the last few days have been for just straight equations with one variable. These are equations with the x and the y. So the solutions in this case mean the x is 5 and the y is 7. So we have two numbers that have to get substituted or checked. So you're not solving anything like we have been the last few days. It says choose the equation that has solutions 5, 7 and 8, 13. So if you were to substitute five for x and 7 for y, the equation would be true. That means the left side and the right side would still equal each other. And you also have to substitute 8 for x and 13 for y, and the equation is true. So you're going to go through your equations and you're going to say, okay, well, x is 5, y is 7. Substitute, do the math. If the left and the right side equal each other, then test out those points. And see when you substitute them in if it's true. So for example, if we look at B, I'm going to take 5, 7 and substitute. So the y is 7. 5 plus 2 is 7, so that checks out. So 5, 7 is a solution of B. Now we need to test 8, 13. So y is 13, x is 8. 8 plus 2 is 10. 13 does not equal 10, so B is not an option. You're going to do this process until you figure out which of those equations has 5, 7, and 8, 13 work. Little review for number 6. The length of ribbon is cut in 2 pieces to use in a craft project. The graph shows the length of the second piece x for each length of the first piece y. How long is the ribbon? Explain how you know. So you got to take a look at your graph and length of the first piece, length of the second piece. So ribbon is cut into 2 pieces. The graph shows the length of the second piece for each length of the first piece. So what this means is right here, the first piece is 15 feet and the second piece is 0. For example, right here, the first piece is 8 feet. The second piece is 7 feet. So that's kind of how this graph is going to be read. We have 2 pieces of ribbon. So how long is the ribbon? Explain how you know. So both pieces, if you were to calculate the length of the first piece and the second piece together, how long would the total amount of ribbon be? That's all I can say about that one. B, what is the slope of the line? Don't forget with the slope, this is where you calculate your slope triangle, vertical over horizontal, and explain what the slope of the line represents, why it fits the story. So don't tell me in general what the slope represents. In this situation, what did you get for B? What do the numbers in B even mean? And that's it.